This video provides an overview of a study commissioned by the Air Movement and Control Association in regards to COVID-19 guidance for large diameter ceiling fans. This study is a numerical computational fluid dynamics study of particle and aerosol transmission in a typical warehouse space with large diameter ceiling fans, also known as LDCF, which are fans greater than 7 feet in diameter. These mid-size warehouse spaces are the backbone of manufacturing supply chains and e-commerce fulfillment systems, both of which have been important in responding to and weathering the COVID-19 pandemic. To ensure the integrity and accuracy of the study, AMCA formed one team of experts across the HVAC industry to ensure the proper selection and application of the products, and another team of experts in airflow modeling, infectious disease transmission, and indoor air quality. Members of these teams include leading academics, members of the ASHRAE Epidemic Task Force, and notably, engineering leaders from Big Ass Fans, a proud member company of AMCA International. The modeling environment is based on the U.S. Department of Energy Reference Warehouse Building for energy modeling studies. The building measures approximately 50,000 square feet and is 28 feet tall. Two 20-foot diameter AMCA-certified LDCFs are modeled as they would be installed near the docks and prep areas in a typical warehouse application. The building is modeled in Chicago, Illinois with TMY3 climatic data. Simulation results are reported for both the whole warehouse breathing zone and the breathing zone in a defined work area where workers are present. Most of the results are focused on a work area with 6 occupants, one of which is presumed infectious, arranged in 2 sets of 3 across a conveyor from each other, as shown here. LDCF operation covered 3 speeds, 100%, 20%, and 0% of the max RPM in both the downward and upward blowing configurations. The results of the study show a clear relationship between 2 steady variables, fan speed and direction, and infection risk. The mechanics of this relationship are based in both limiting the residence time of high concentrations of infectious particles in the occupant breathing zone and utilizing the air mixing provided by fans to dilute localized concentrations of particles to the entire building air volume, driving particle concentrations lower on a given dose-response curve. With regards to LDCF speed, fan operating points that result in higher airspeed at the occupant level reduce occupant exposure to infectious particles and encourage the most comprehensive air mixing in the warehouse. This is especially true for applications where airspeed is greater than 0.9 meters per second in the working area breathing zone. With regards to LDCF operating direction, it was shown that the downward blowing configuration resulted in better whole space mixing and therefore reduced occupant exposure to infectious particles. For building owners and operators, the AMCA International study makes the following recommendations for LDCF operation that are fully supported by Big Ass Fans engineering leadership. If most occupants are located close to a fan, operate the fan downward at high speed during summer and at the highest speed not causing occupant discomfort in either forward or reverse direction, whichever was used prior to the pandemic, during winter. And if most occupants are located far from a fan, operate the fan downward at high speed during summer and at the highest speed in either forward or reverse direction, whichever was used prior to the pandemic, during winter. This video provides a brief overview on this study and the recommendations. To view a copy of the full white paper on the study, contact your TBC supply representative.